Hi, my name is Kara Foley, and I'd like to share my final project for GIS510. I'm interested in an invasive aquatic weed called Hydrilla that's been found in many water bodies throughout the state of North Carolina. Many people who are concerned with North Carolina's freshwater resources are also concerned about the spread of Hydrilla because it grows very rapidly and it quickly takes over lakes and rivers, and it's also very difficult to manage once it's become established within a system. My 3 analysis questions for my project are: 1. What are the ecologic and geologic attributes that surround areas where we know that Hydrilla has invaded water bodies in North Carolina? 2. What water bodies in North Carolina have the potential to be invaded by Hydrilla? And 3. What is the total area in which Hydrilla could be a problem throughout the state if left unmanaged? Here are the data layers that I use for my project. First, I have a layer that depicts the different geologic formation types throughout the state of North Carolina. I focused on this geocode attribute to keep it simple because if you look at the attribute table of this data layer, it gets pretty complicated and you could get really into it if you wanted to, but I didn't. The second is the water quality throughout the state of North Carolina. I looked at the BIMS class attribute, which are just the classifications of every water body throughout the state. Third, I looked at this fish communities data layer, which are locations where fish were sampled and given an IBI score, which is basically just a biodiversity rating at every location that they have sites throughout North Carolina. These 3 data layers all come from the North Carolina Department of Environmental Quality. And then lastly, I have the areas where we know Hydrilla has invaded North Carolina in the past. This data comes from the USGS, and it shows where all the locations are, and if you look at the attribute table, you can get a little bit more details of when it was found and the locality of every infestation. It's pretty interesting. But anyway, from these layers, I found which attributes intersected the water bodies where Hydrilla has been found in the past, and I made new data layers where only the suitable attributes are shown. So I have the suitable geology, suitable water quality, and also suitable biodiversity ratings. From these locations, it was found that the invasive aquatic weed Hydrilla has been found in water bodies that have been classified as highly or moderately developed water supply impoundments used as primary or secondary recreation and are critical areas. Also, Hydrilla was commonly found in areas that possess the geocode that describe where mica and gneiss deposits are. And lastly, the common IBI score or biodiversity score near areas where Hydrilla has invaded ranged from fair to good. And then from these characteristics, I identified 95 additional water bodies where Hydrilla could potentially invade in the future because they possess all of the attributes of a suitable area for Hydrilla. So as you can see, I've answered 2 of my questions here, questions 1 and 2, but because I couldn't really depict my results for question 1 in a map very well, I went ahead and included question 2. So when you look at my web map here, I have the same data layers included, and I also turned on the clustering options, so when you see these symbols for potential Hydrilla infestation or historic Hydrilla infestation, when they're bigger, that means they're more in that area. You can zoom in and see more details. Yeah, so you guys can play around with my web map, and if you can maybe see where your favorite water body is and if it has had or could have Hydrilla in the future. So as for my question 3, I hypothesized that areas of potential infestations could be quite large, which would ultimately be very costly and have a negative impact on the aquatic ecosystems throughout the state. I'm hoping that this analysis helps inform management decisions for Hydrilla in the future. And that's all I have. Thank you for listening.